Hey, welcome back to your favorite fundamentals college math class. We're going to take a look at area and circumference today, this geometry section. Let's start out using some area formulas. First of all, the area of a rectangle, as you might recall, is length. So whatever your length is times whatever your width is. For a square, you've got just the side times the other side, so side squared. So for example, if this is 3 and 3, you've got 3 squared. 3 times 3, we got 9. This is in inches. That'd be 3 inches times 3 inches, 9 square inches. And you can see that is representing, there's 9 of those square inches, right? So it's representing that area. If this was like 9, that was 3, there'd be 27 of those square inches, right? It's like how much grass do you have or whatever. How much do you have to paint, right, in terms of square feet, so on. All right, let's solve this area problem here. Decide to cover the path shown in bricks. Find the area of the path. So what I'm going to do is I'm going to draw a line right here and make this into two rectangles. So I'm going to find the area of this rectangle first. So we've got length times width. And then I'm going to add in the other one. Okay. So this one, if I was doing it in a different color, then I'd do that one. Okay. So let's go to this length times width. We got 13 feet times 3 feet. 13 feet times 3 feet. So we've got 39 feet times feet square feet. Plus, now I've got to do the other one. Do that in red here. So we've got this length right here. Now notice from here to here is 6. But we do know that's 3 feet because over here. So this whole length here, 6 plus 3, we got 9 feet. So it's 9 feet length, 3 feet wide. So length times width there, 9 feet times 3 feet, we've got 27 square feet. So this area all ends up being 39 plus 27, so 66 square feet is the area that we need to cover in bricks. All right, area of a parallelogram. So parallelogram means the opposite sides are parallel, if you remember. So both sides are parallel, and then the right and the left are parallel, right? Now the area of a parallelogram is the base times the height, but the height is this perpendicular. So it's from one of these vertices and it's making the 90-degree angle. You've made a 90-degree angle there. Okay. So it's the base times the height. Again, just remember that's the perpendicular, right? From the vertex down to the other base, making a perpendicular. And if you think about this, it's the same formula as a rectangle. If you were to just take this piece and put it over here, see how you've got this rectangle, so you got the base times that perpendicular height, just like with the rectangle. Works with the parallelogram. You just got to remember this is your height right there. Okay, so area is base times height. Height here is your perpendicular. So you've got 32 square centimeters is your area of that parallelogram. Okay. All right, if we were to take a parallelogram, just cut it in half, and just look at half of it, half the area, right? There'd be a triangle. So area of a triangle is 1/2 base times height. 1/2 base times height. Again, your height goes from a vertex and makes that perpendicular, right? That's your height of a triangle. So 1/2 base times height. Who's your height here? That's your height, the 10 meters. So area 1/2 base times height. 1/2, our base is 16 meters. Our height is 10 meters. So it looks like we have 80 square meters. And I love my blue. I gotta go back to my blue. All right, how about area of a trapezoid? So if you think about area of a trapezoid meaning we got just one set of sides opposite in this quadrilateral. And if you were to split that, right, you'd have two triangles here, right? You'd have the one in yellow that I've outlined. So we have 1/2 base, which is A, times the height H, right? So 1/2 AH. And then we have the one in pink outlined here. So 1/2 B, the base, times its same height H, right? 1/2 BH. So if you add those two together, you got 1/2 AH plus 1/2 BH. If you factor out 1/2 H, you're left with this formula for the area of a trapezoid. 1/2 H parentheses times the quantity A plus B. Right? So let's do one right here. 1/2 the height and A plus B. Now remember, A and B, those are your parallel bases. Okay, so here's your A and your B, or vice versa, right? But the 32 and the 46 are the A and the B, parallel sides. And then your height here, who's your height? Is it 13.4, 13 feet, or 17 feet? Well, it's the perpendicular, so there's your height, 13 feet. 13 feet. Now we've got A and B, so we got 32 plus 46. Those are in feet, so that's what, 78 feet, 13 feet. We got half of that. So I'm gonna go half of 78 because it goes into that. What's that? 36 times the 13. Let's see if I got it written down. Yeah, 507. 507 square feet area. So half times 13 times 78. Punch that in. There it is. Yeah. All right, circle. So we got a circle is a set of points, set of all points that are equally distant from a given point. So if you've got this center here, it's a collection of all the points that are the same distance, right? Same distance away, which we call that distance radius, of course. Same distance away, and once you draw them all, of course, it becomes solid because it's representing every point. So again, this is our radius r. The diameter of a circle is just double the radius, right? So that's your diameter all the way across. But it's going through the center of the circle there. Okay. Find the circumference of the circle with a diameter of 40 yards. Well, the circumference of a circle is 2 times pi times the radius, or if you want, you can just go, since double the radius is the diameter, it's pi times your diameter. And we have a diameter of 40 yards, so let's just use pi times 40 yards. So 40 pi, punch in 40 pi, use your pi button on your calculator, and you get 125.663706. Well, anyways, this keeps going. Yards, right? And that's the circumference. That's representing how many yards is around the circle there. What's the circumference? It's kind of like perimeter for polygons, right? It's the circumference for circles. It's that many yards. And then usually, in your homework, it's going to have you just approximate that to the nearest 10. All right, so let's go, if we go to that digit, then the 6 makes this bump up 125.7 yards. We're rounding to the nearest 10th on that one. All right, let's finish here with talking about a problem using the formula for a circle's area and figure out which one's a better buy. You're offered a large pizza with a 16-inch diameter for 15 bucks. Or do you want to go with a medium pizza with an 8-inch diameter? It's 7.50. So which one's the better deal? Well, what you need to think about is you want to think about your unit price. If you remember, like if you go into a grocery store, a lot of the time when it's labeled I don't know, whatever you're buying, maybe you're buying some chicken or whatever, there's a unit cost. Let's say the chicken costs $16, but if you look on that sticker, it'll also show you the price per pound, right? That's the unit cost. How much is it costing me per pound or per ounce if you're buying whatever, some liquid or whatever, right? That's the unit cost. So here we want to know the cost per considering the area, right? How much pizza am I getting? In other words, per square inch, right? So if I have a pizza, how much does one of these square inches cost? That's what I really want to know. And then I know the better deal, right? So the first thing I need to do is we need to find the area of these. Let's do the area of the large one. And then we can get to our unit cost here. So the area of the large one, area of a circle, the formula is pi times the radius squared. Okay. So in this case, for the pizza, let me erase this part here. For this large pizza. So the large pizza said it had a diameter of 16 inches. So that means the radius, right? The radius would just be 8 inches. So the area would be pi times 8 inches squared, right? 8 times 8, 64 pi square inches. Now punch in, use your pi button on your calculator. 64 times pi, in 201.062 square inches. Okay, that's the total area of the large pizza. Now let's do the area of the medium pizza. Okay, so we got a medium pizza. It's got an 8-inch diameter. So that means the radius is only 4 inches. So the medium area, pi times radius squared, pi times 4 inches squared, 16 pi square inches. Use your pi button here. You got 50.265 square inches. That's your area. Okay, now let's do the per unit cost. In other words, the cost per square inch. And since I got the red here, let's start with our unit price. Okay, we know we're getting 50.265 square inches, but the cost of this thing for a medium pizza is 750. Right, so it's 750, and I'm going to divide that by the total area, 50.265 square inches. And so this ends up being, punch this in here, 0.1492 per square inch. In other words, it's about 15 cents per square inch, right? Again, if I was dividing this up, one of these is about 15 cents on that medium pizza. Now let's do the unit price for a large. The large costs $15. We're getting 201.062 square inches. So now I'm going to punch that in, 15 divided by 201.062, and I get 0.0746 per square inch. So about round it to the nearest hundredth here, about 7 cents per square inch. About 7 cents. So one of these 7 cents. So this one 7 cents per square inch. This one was 15 cents per square inch. Who's the better deal? The large pizza in this case, because it's only 7 cents per square inch. Everything else considered equal, right? So now, if you're like me, you're never going to go to Little Caesars Pizza thinking the same. Mathematics has definitely changed. You're going to be thinking about your unit price, right? Anyways, thanks for listening, you guys. That's it for this section. That's just the walkthrough.